In this short video, we're going to see how to use the calculator to graph quadratic functions. The function that I'm looking at right now is in standard form for quadratic. The function does not need to be in standard form for quadratic to find these things out using the calculator. It can be in any form at all. Alright, the first thing, let me note that at the bottom of the page I have listed the keys that we use when we're graphing on the calculator and the keys that we'll be using now. Turn the calculator on, and the first thing you want to do is go to the Y equal key. It does not matter whether you are in real mode or in complex mode, so don't worry about the mode setting. I did at some point under mode put dots instead of connected, and I think I'll leave that because it makes kind of a nice looking graph. Y equals, and then you'll put the value of the function -4 parentheses x minus 5 close parentheses square plus 4. And note that the only variable that you can use in this screen, the Y equals screen, is the x variable. So if it's some other variable in your function like h or g or b or t, use x please to replace it. Alright, and then we go to zoom 6. And let's look at that. Zoom 6, it puts you in a standard window. And I'm going to show you what the window is, but let's go to zoom 6 and hit and wait. Always let it wait. Now this is a picture of the graph, and in the standard window it goes from -10 increments 1 tick mark at a time to +10 in both the x and y axes. If I hit trace right now in this window or in zoom 8 window, it is going to give me my y-intercept. And so I know my y-intercept right now, and I'll write that down. The y-intercept is 0, -96. Okay? To get there appear to be two x-intercepts here. And we'll look at these values first. To get them, we use the calc key, and depending on your model of calculator, it might call it a 0 or a root. On this calculator it calls it the zeros, and it refers to the x-intercepts. And so I'll go down to the 0 and hit enter, and I need to have my cursor on the left side there, so I'm going to move it to the right until I can see it at least. Let's see. There's my cursor. Now you want it to be to the left of the point, so I'm going to move, wait a minute, I'm going to move it to the left with the left arrow, and that anywhere to the left of it, that's fine, and hit enter. And then move it to the right of it. See, it's asking for right bound, but you don't want to go all the way over past the other intercept, and hit enter. And it's going to give you, and then it'll always do a guess first, and then hit enter again, and it will give you the value of the first intercept there, which is 40. So I'm going to put x-intercept, and the first one is 40, and that's what it looked like, because on the graph it looked like 4. And then you can do this again to get the other intercept, second calc, and go down to 0 and hit enter, and then go to the left of the other one. I don't want to be right on this thing, so I'm going to go for left bounds, we want to put a left point and a right point from the relative to that intercept. So we're a little bit to the left of it, so we'll hit enter. And then we'll get a little bit to the right of it by hitting the arrow again several times. And now it's between those 2 points, so we have sort of a guess that it makes. And then it gives us the exact value of the point, which is 60. Alright, the other things that we can find while we're still in this Zoom 6 screen are the value of the maximum or minimum. And this particular function is opening downward, and so it has a maximum. And you probably saw that on the calc function. And so we'll go down to number 4, the max. Hit the arrow and just go down and hit enter. And it's going to ask us for a left boundary on that max. So we want to move the left arrow and get the point to the left of that max. Some functions have more than one maximum. So we'll hit enter because that's to the left of it. And then we'll move the cursor to the right of it and hit enter again. And then we'll let it guess, and it'll give us a value. And as you saw in other things, sometimes values don't come back as true as they should on this. And so 4.99999 is going to be 5 for us, because you're going to be checking this against your work, and sure enough it is 5. So the maximum, or the vertex, why don't I just call it vertex, but maximum or the vertex of the parabola is the point 5, 4. And hence the axis of symmetry is x equals 5. I'll just call that the axis. So you're able to get a lot of information off this graph. Now, I want to point out to you one thing you can't get from this graph very well. Let's hit the trace key. The values for graphing are not really ideal here. All right, so let's hit Zoom 6 again, and this time we're hitting it to center the graph. And then we're going to hit Zoom 8. Enter. Okay, you always follow it by enter because it hasn't regraphed yet. And you get a window that maybe doesn't have as pretty looking a graph. It's got fewer tick marks. If we actually check the window key, we can see that it goes from -47 to 47. The other window went from -10 to 10, so it's kind of pinching our graph together. And then if you go to window, you want to hit graph to get back to the graph that you're already drawn. And then, but the nice thing about this is when we hit trace, we see some values that we might want to use in a table of values for our function. Our y-intercept is way off the graph. We can put it in our table of values, but it's not very useful because we're probably not going down to -96. And then we can move to the right. 1 plots to -60. You can see you're getting really nice integer values here. Let's see what 2 plots to. Keep going to the right, 2, -32. And so you could get some points you could actually plot on a graph if you had to graph this. 3, -12, 4, 0. There's our intercept. Five, 4, 6, 0. 5, 4 was our vertex, 6, 0 was another point, and so on and so forth. Let's do one more point. 7, negative 12. Okay, so you could, when you have a curve, you need a bunch of points. 2 points or 3 points will not do the trick. So if you actually have to graph this, you need to have enough points where you can give a fairly good representation of the graph. You could play this video over. I didn't miss anything that I know of, so you should be able to see how to check any quadratic function that you might have. And remember, it does not have to be in standard form for you to verify that all of these characteristics of the function.